through the second derivative test for local extrema. So if you still remember, okay, before this we have gone through first derivative test and we have seen how it has been used to decide whether a point is a maximum or minimum. Okay, that is by the trends of the graph itself, whether it is increasing for a certain interval and then decreasing for another interval, and how we can make the conclusion about the point in the middle or the extreme points that we have in our graph. So for the second derivative test, okay, we are going towards the same direction, that is to decide whether our function has a maximum or minimum, or in other words, okay, simply said, local maximum and local minimum, because if we are moving towards absolute extremum, we also need to consider the endpoints, okay, finding what are the domains. Alright, let us go through this formal theorem of second derivative test for local extrema. So it says here, suppose the second derivative f double prime is continuous on an open interval that contains a point x equal to c. So if f prime c equal to 0 and f double prime c less than 0, then f has a local maximum at x equal to c. So let us just try to decide what is the meaning of this first point. So first we have f prime c equal to 0. So if you still remember, f prime c equal to 0 can be indicated as a critical point. Alright, so you can see it as a critical point. It can be either maximum or minimum. But then we rely on the second condition that we have here, that is f double prime c less than 0. So if you still remember, if less than 0, it means that it, okay, let me put here for number 1, it concave down, right? The value of f double prime c is less than 0, so it concave down. So the shape is something like this one, and because f prime c equal to 0, we know that due to this concavity, okay, downward concavity, f has a local maximum at x equal to c. Okay, I think that's pretty obvious. And of course, for the second one, we have case of f double prime c greater than 0. That means it is concave up. Okay, something like this one. So we also have the condition f prime c equal to 0, and again it is obvious that f has a local minimum at x equal to c, because we also said previously that f double prime is continuous on the open interval that contains x equal to c. And then we have the third condition, okay, where we cannot make any decision whether it is a local maximum or local minimum, but let us go through. In this case, we also have f prime c equal to 0. But now, instead of having positive or negative value for our f double prime or second derivative, we have f double prime c equal to 0 instead, something in the middle. Then the test fails. Okay, what does it mean? Okay, we cannot make in conclusion because we don't have enough information of that particular point. Okay, if for the first one we have local maximum, second one we have local minimum, but now we don't have enough information. The function f may have a local maximum, a local minimum, or neither. It means that we need more information to decide on this particular point x equal to c. So these are some illustration on second derivative test for local extrema. So for the first case that we have just now, we have f prime equal to 0, f double prime less than 0, concave down. Okay, let me put here down. So we have this kind of shape. And then for the second one here, we have f prime equal to 0 and f double prime greater than 0. Okay, concave outward. And we have the conclusions for both. That is the first one for local maximum and the second one is local minimum.